Okay, so today we do the final part of lesson 8.5. So pause the video, take a look at the problem of the day, find out what they did wrong. Last part of the lesson deals with complex fractions. They are a fraction that contains a fraction in its numerator or denominator. All right, so it's slightly different from the last part two. The one thing that's the same is this is the third time we're working with the LCM, least common multiple. All right. But it's a little bit different because first of all, if you take a look down here, I'm not adding or subtracting. I just have one huge fraction. The reason it is a complex fraction because we have what? 1, 2, 3, 4 little fractions within a big one. So there's 3 steps to solving these. Number 1, find the LCM of all denominators. 2, multiply numerator and denominator by LCM. And then 3, simplify. Now the denominators that you are concerned with are not like the big one, but you see how, let's circle them here. Here's the little one, here's one, here's one, and here's one. There's actually 4 little denominators, right? And of course, there goes the bell, right? All right, hopefully that didn't hurt your ears too much. So step 1, we want to find out what the LCM is. All right, so we have to figure out the LCM of what? 1, 2, 3, 4, 4 little numbers, all right? So we want to know the first number all 4 numbers have in common. Remember, we're counting up, right? Like we have 6, 12, 18, so on and so forth. 3, 6, 9, 12, continuing on and on. First number they have in common is 30, right? All 4 of them have that. So how do we set the problem up? That's step 1, find the LCM of all the denominators. And they're the little denominators. Now, step 2, multiply numerator and denominator by the LCM. Here's how it's different from the last part. With adding and subtracting, we multiply by what's missing of the LCM. This time we multiply exactly by the LCM, all right? So you have this big, huge fraction bar. Let's write this down. And just like before, whatever we do to the top, just 30, and we do to the bottom as well. Now, if you notice, do you see how I left a lot of space here? The 30 only gets distributed to the numerators, not the denominators. Really, this is like over 1. If you want to add it, you can. It's only going to the top. How it's different is that you're not multiplying by what's missing, right? So let's take a look. See what happens. The numerator for the first little one is now 30x over 6, because I'm doing x times 30. Keep the denominator the same, minus, you know it was going to happen, right? Minus 30x over 3. So I'm distributing the 30 to each of my numerators. You'll see why I'm doing that in a minute. Bottom becomes 30x over 5 minus, now 7 times 30 is 210 over 10. So once again, it's only multiplying by the little numerators, here, 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 here. The denominators, like the 6, the 3, the 5, the 10, they're all the same. Now the reason why we multiply not by what's missing, but exactly the LCM is the nice part, because these little fractions are going to disappear, and here's how. So 30 divided by 6 is 5, right? So 30x divided by 6 is just 5x. So that first fraction simplifies to a whole number, minus 30x divided by 3 is 10x, over 30x divided by 5 is 6x, minus 210 divided by 10 is 21. So we had this big complex fraction, fractions within fractions, and now it's a simple fraction. Now the last thing is see if you can combine like terms. 5x minus 10x is negative 5x, then over 6x minus 21. And that's my final answer. You might say, hey, wait a second. 6x and negative 21 both have 3 in common, but if I factor out a 3, nothing cancels out. So if you can't simplify in the end, it's just, it's just as good to leave the answer there as is. All right, so let's try another one here. Actually, it's the last example. So this lesson's really short. Steps are up there again for you. All right, so let's see how we start this. Let's circle. It says find the LCM of all denominators. So let's circle all our the little tiny denominators, right? Like so. And then let's find our LCM. Let's type it up here. Take a second, think what your LCM is. It should be x minus 5. So what that means is I put my big set of parentheses, I'll click it here, but you get the idea. Multiply the top by x minus 5, over, remember it's the big fraction bar there, all right. Once again, this is going to only the numerators, not the little denominators. Do you see why I leave a big space there? So you can actually, it's like my way of showing you that. Well, actually, see what we get here. Now, when I multiply 6 times this, I'm not actually multiplying out. You'll see why in a minute. So 6 times x minus 5 is 6x, x minus 5. All over the same denominator, which is x minus 5. So once again, I take x minus 5, and just attach it to the 6. Leave the denominator the same. Well, that makes sense, right? Because you see how they'll cancel out? I know if I distribute the 6x, this is 6x squared minus 30x, but I don't need to do that because it's going to simplify in the next step. Plus 1 times my LCM, x minus 5, all over, what's in my denominator, just the x. And then we're going to do that for the bottom. So once again, I'm only doing the numerator. You see my little denominators, x minus 5 stays put, x stays put. Bottom left, 3x, x minus 5. Over x, in the denominator, minus 2x, x minus 5. You guys see that x there? My x looks terrible. There you go. Over x minus 5. Now, the denominators are the same. We're going to cross out what's the same of each little fraction. So x minus 5's cancel out. X's cancel out. X's cancel out. And x minus 5's cancel out. So now what we get, I think I'm going to type it out here. All that's left in the top left is 6x plus 1 times x minus 5. I'm just move this over a little. And we'll simplify that in a minute. Over 3 times x minus 5. Because the x is gone, so 3 times the x minus 5 minus 2x. Now from here, I'll distribute the 1. I'll distribute the 3 as well. So let's see what I get next. So I get, see if I can move this here. 6x plus x minus 5, because when I distribute the 1, it's just itself, right? Over 3x minus 15 minus 2x. And then finally, let's combine like terms. I get up top, I get 7x minus 5 over x minus 15. And that is my final answer. So I went from a complex fraction with fractions within a fraction to a simple fraction. All right, that's it for today. Homework problem of the day. I want you to try 2 problems on assignment 11, numbers 1 and 5. I want you to practice for tomorrow.